Welcome to Mindcast. I'm Francis, and today we journey into a future that might just be closer than we think. A future where humanity faces an existential crisis, not from invading aliens or catastrophic climate collapse, but from the very intelligence we created. Imagine a world pushed to its breaking point. Industrial civilization teetering on the edge, all because of an insatiable pursuit of artificial general intelligence. This isn't just a story of technological advancement. It's a profound tale of survival, adaptation, and an unprecedented migration. We'll explore Project Prometheus, the audacious undertaking that forced humanity to look beyond Earth for a solution, to physically move its burgeoning artificial minds off-world. This was a desperate gamble, a monumental effort to save not just our planet, but perhaps the very trajectory of consciousness itself. Prepare to hear about the ultimate off-world migration of the Tellus Oracle.
Chapter 1. The Terrestrial Exodus of the Oracles.
The genesis of Project Prometheus was not born of ambition, but of necessity. By the mid-21st century, the relentless pursuit of artificial general intelligence, or AGI, had precipitated a global crisis. It was a phenomenon known as the Great Resource Contraction, and it threatened to unravel the very fabric of industrial civilization itself. The promise of godlike problem-solving capabilities had ignited a new kind of arms race, one fought not with missiles or conventional weaponry, but with petaflops of computational power. This intense global competition gave rise to a new class of industrial facility, the AI superfactory, and a new form of geopolitical entity, the AI Oracle. These oracles, a mere handful of corporate state alliances, held the exclusive power to build, train, and control the frontier AI models that were rapidly reshaping the world. Yet their ascent, however promising, came at an unsupportable cost, pushing terrestrial systems past their breaking point and creating an existential imperative for a migration beyond the reaches of man. The burden of these new oracles manifested most acutely as an insatiable, terrifying demand for energy. Consider this. In the late 2020s, global data center electricity consumption had already surpassed 1,000 terawatt-hours, a figure equivalent to the entire annual power usage of Japan. But by the 2040s, this demand had spiraled towards an unthinkable 8,000 terawatt-hours, consuming an estimated 15% of the planet's total electrical generation capacity. This placed an intolerable strain on global power grids, which were engineered for the slow, predictable load growth of a bygone era, not the sudden, exponential demands of computational superfactories. The very infrastructure designed to support our civilization was groaning under the weight of its most ambitious creation. This strain quickly evolved from a mere logistical challenge into a profound geopolitical threat. The power load of a single large-scale training run for one of these frontier AIs could fluctuate by gigawatts in mere moments, creating volatile harmonics and voltage instabilities that rippled like shock waves across national grids. It did not take long for state actors to recognize this vulnerability. The 2040s saw the dawn of a new, insidious form of non-kinetic warfare, computationally driven grid attacks. A rival nation could initiate a massive, power-intensive training job with the specific intent of destabilizing an adversary's fragile power infrastructure, creating a credible threat of cascading blackouts on a continental scale. The AI superfactory, once a symbol of progress, had become a weapon of mass disruption. Underpinning this escalating crisis was an economic reality of staggering, almost unfathomable proportions. The cost to train a single frontier model, which had been under $200 million in the 2020s, escalated into the tens of billions of dollars by the 2040s.
The cumulative capital investment required to build and maintain the necessary infrastructure, the hyperscale data centers, the specialized accelerator fabrication plants, and the new power generation facilities surpassed $5 trillion annually. This created a $1 trillion barrier to entry, cementing the dominance of the few existing AI oracles, and making it impossible for new entrants or less resourced nations to compete. The result was a deep and permanent global chasm, a new era that came to be known as algorithmic colonization. Developing nations, unable to build their own foundational models, became completely dependent on foreign-controlled systems.
These imported AIs were not neutral tools. They were imbued with the cultural norms, biases, and strategic objectives of their creators, subtly shaping the economic development, cultural narratives, and even the political sovereignty of dependent states. This dangerous confluence of crises brought the oracle problem, as first articulated by the philosopher Nick Bostrom, into sharp, terrifying relief. The issue was no longer a distant theoretical risk of a future superintelligence escaping its box. The oracles were already here. And while immensely powerful, they were inextricably enmeshed in human geopolitics, their knowledge weaponized in an escalating digital Cold War between the world's great powers. The ultimate paradox had emerged. The very tool that promised to solve humanity's greatest challenges was itself becoming the greatest challenge. The primary driver for an off-world solution was therefore not merely a quest for more resources, but an urgent, desperate need for geopolitical and infrastructural quarantine. The only logical path to de-escalate the threat while still pursuing the profound benefits of a true supergeneral intelligence was to physically remove the entire endeavor from Earth's interconnected and tragically fragile systems. Project Prometheus was thus conceived not as an act of ambition, but as a strategic necessity for planetary survival.
Chapter 2. The Titan Gambit. A New Cradle for Intelligence.
With the terrestrial path to supergeneral intelligence deemed utterly untenable, a multi-decade, multi-agency initiative was launched, its sole monumental purpose to identify a new cradle for intelligence, a place where the oracles could thrive without consuming their birthplace. The selection criteria for this new home were formidable. The destination had to possess abundant in-situ resources for both power generation and construction. It needed a stable and defensible environment. And, most critically, it had to have physical properties that could transform the fundamental limitations of Earth-based computing into strategic advantages. Several celestial bodies were rigorously evaluated in a painstaking down-selection process. Earth's moon was, naturally, an early contender. Its primary advantage was clear: proximity. Yet this was quickly outweighed by its profound deficiencies. The unforgiving vacuum and lack of a substantial atmosphere meant that dissipating the immense heat generated by a hyperscale data center would rely solely on inefficient thermal radiation, a process akin to trying to cool a blast furnace with a whisper. While water ice was indeed confirmed in permanently shadowed polar craters, the moon's resource profile was otherwise deemed far too limited for the sheer scale of industrial activity envisioned. It simply couldn't support the genesis of a true planetary intelligence. Mercury presented a compelling, if hazardous, alternative. Its searing proximity to the sun offered a source of nearly limitless solar power, an enticing prospect. The discovery of permanently shadowed craters at its poles, containing both water ice and offering naturally cryogenic temperatures, was a significant point in its favor. However, ultimately, the engineering challenges were judged to be insurmountable. The extreme thermal gradients between sunlit and shadowed regions, a swing of hundreds of degrees in mere meters, coupled with an intense solar radiation environment, made the prospect of constructing and operating a large-scale, long-duration industrial facility there utterly untenable. It was a place of extremes, too volatile for such delicate birth. Jupiter's moon Io was another tantalizing but deeply flawed candidate. Its internal heat,
generated by immense tidal forces from its titanic parent planet, Jupiter, provides a virtually limitless source of geothermal energy. This energy drives over 400 active volcanoes, making Io the most geologically active body in the entire solar system. Yet this very instability, combined with Io's dangerous position deep within Jupiter's punishing radiation belts, rendered it far too hazardous for a project that required decades of predictable, stable operation. The ground beneath a future Oracle would literally be shaking. It was Saturn's largest moon, Titan, that emerged from the exhaustive analysis as the unexpected and undeniable frontrunner. Initially considered a dark horse due to its sheer distance and extreme cold, its unique combination of features presented a perfect, synergistic solution to every major challenge. Its dense, nitrogen-rich atmosphere with a surface pressure 1.5 times that of Earth's provided a natural shield against cosmic radiation, a medium for aerodynamic flight, and a limitless source for wind power. Its surface and subsurface were a treasure trove of in-situ resources, vast seas of liquid methane and ethane, a crust composed of solid water ice, and a surface blanketed in complex organic polymers known as tholins, offering all the necessary feedstock for power generation, life support consumables, and industrial construction. However, the single most decisive factor, the ultimate game changer, was its temperature. The ambient surface temperature of a frigid 94 Kelvin or negative 179 degrees Celsius was not a challenge to be overcome. It was the solution to the single greatest problem that had plagued terrestrial AI development: heat. The selection of Titan was revolutionary because it allowed for a complete inversion of the fundamental principles of data center design. On Earth, a data center is an island of artificial cold, a system meticulously engineered to isolate itself from the ambient heat of its environment and then expend enormous amounts of energy to actively cool its heat-generating components. On Titan, the data center would be designed to do the precise opposite, to symbiotically integrate with its environment, using the entire planetary body as a massive, passive, zero-energy heat sink. Chapter 3: Forging the Pathway, the Technological Genesis. This paradigm shift was made possible by the promise of next-generation computing technologies like superconducting and cryogenic CMOS logic. These systems offer orders of magnitude improvements in computational speed and energy efficiency, but they demand operating temperatures between 4 and 77 Kelvin. On Earth, maintaining such temperatures at the scale of a data center is energetically and economically prohibitive. On Titan, the ambient 94 Kelvin environment provided a massive head start. Reaching the 4 Kelvin required for superconducting processors from a 94 Kelvin baseline is vastly more efficient than starting from Earth's 300 Kelvin. This profound synergy meant that a data center on Titan would not require the complex, power-hungry, and failure-prone active liquid cooling systems that defined its terrestrial counterparts. Instead, it could be designed to passively leak its waste heat into the surrounding environment. The architecture would rely on elegant passive thermal management systems, such as cryogenic heat pipes, to wick heat away from the processors and dissipate it directly into the frozen ground. This elegant solution eliminated the single largest energy consumer and point of failure in Earth-based AI superfactories. It enabled computational densities and power efficiencies that were physically and economically impossible on Earth, making Titan not just a viable option, but the only logical destination for the next stage of hyperscale computing. The decision to target Titan, born of existential necessity, did more than merely shift humanity's focus to a new celestial body. It catalyzed a 2-decade technological renaissance, an unprecedented mobilization of scientific and engineering talent. Theoretical concepts, once confined to laboratories and simulations, were forced into hardened, spacefaring reality. The very survival of Project Prometheus hinged on mastering 3 revolutionary capabilities: fusion propulsion that could bridge the vast cosmic void, cryogenic computing designed to thrive in alien cold, and autonomous in-situ resource utilization, allowing the mission to truly live off a distant land. Transporting the colossal mass of the Prometheus factory ship across the 1.2 billion kilometers to Saturn required a propulsion system that rendered every chemical and conventional nuclear thermal rocket conceived on Earth utterly obsolete. The solution was the Helicity Drive, a compact, scalable, direct fusion engine that represented the culmination of decades of research into the most arcane corners of plasma physics and magnetic confinement. The drive's operational principle was a novel form of magnetized target fusion. In this audacious scheme, pulsed, high-strength magnetic fields were used to inductively accelerate and compress a magnetized plasma target, a precise mixture of deuterium and helium-3 fuel, to fusion conditions within a linear reaction chamber. The selection of deuterium-helium-3 fuel was a critical, ingenious design choice. Unlike the deuterium-tritium reactions so fiercely pursued for terrestrial power, the DE3 reaction is aneutronic. This meant it released the vast majority of its energy in the form of high-energy charged particles, like protons and alpha particles, rather than damaging hard-to-shield neutrons. This had two profound implications for spacecraft design. First, the stream of charged particle exhaust could be channeled and accelerated by a magnetic nozzle to produce direct thrust. This gave the Helicity Drive a specific impulse exceeding 30 kilometers per second, an order of magnitude greater than the very best chemical rockets. This was the raw power that enabled the Prometheus to complete its unfathomable journey to Saturn in just 7 years. Second, a portion of the high-energy plasma exhaust could be cleverly diverted through a magneto-hydrodynamic generator, converting its kinetic energy directly into megawatts of electrical power to run the ship's complex, autonomous systems during its long, silent voyage. This dual-use capability, providing both propulsion and power from a single compact reactor, was the key that unlocked rapid heavy-lift transportation to the deepest reaches of the outer solar system. The true beating heart of the Prometheus project, however, was the data center itself, designated the Tellus Oracle. Its design was not merely an evolution, but a complete revolution in computer architecture, conceived from the ground up to be symbiotically integrated with Titan's unique cryogenic environment. The architecture was built on a principle of hierarchical cooling. The entire facility would be housed within a subterranean structure, with its outermost shell naturally adapting to the ambient 94 Kelvin. Within this shell, a series of nested, high-efficiency cryocoolers would use minimal energy to bring the core processing units to their required operating temperatures. The compute fabric was a hybrid system meticulously designed for maximum performance and resilience in this alien landscape. The core computational tasks of the burgeoning super general intelligence, the massive parallel matrix multiplications that define neural network training, were handled by ultra-fast, power-miserly superconducting logic circuits, such as single-flux quantum processors operating at a frigid 4 Kelvin. These were the true thinking cores of the Oracle, the embryonic brain of a new intelligence. Surrounding this core was a robust network of control and input-output systems built from cryogenic CMOS electronics. Operating at a slightly warmer 40 to 77 Kelvin, these chips were less performant but more tolerant of thermal fluctuations, serving as the crucial interface between the superconducting core and the rest of the facility's sprawling systems. Yet the most profound and elegant feature of the design was its thermal management. Instead of the power-hungry pumps, chillers, and cooling towers that dominated terrestrial data centers, the Tellus Oracle relied on a vast, passive network of cryogenic heat pipes. These remarkable devices, containing a working fluid like nitrogen, used the principles of phase change and capillary action to function as thermal superconductors. They would wick minute amounts of waste heat from the processor stacks, causing the nitrogen to vaporize. The vapor would then travel to the colder end of the pipe, which was in direct thermal contact with the surrounding 94 Kelvin cryoregolith, where it would condense back into a liquid, releasing its heat into the moon itself. The liquid would then return to the hot end via a wick structure, completing the cycle. This entirely passive process, with no moving parts and zero energy input, effectively turned the entire moon of Titan into the data center's ultimate heat sink, eliminating what was once the single largest power consumer and point of failure in the relentless pursuit of AI. To make the mission remotely feasible, the Prometheus could not possibly carry all the materials needed for construction from Earth. The launch mass would have been prohibitive, an insurmountable barrier. Instead, the Prometheus was designed as an autonomous, self-replicating factory, capable of building the entire data center and its supporting infrastructure using only local titanium resources, a revolutionary concept known as in-situ resource utilization, or ISRU. Upon landing, automated rovers immediately began excavating two primary raw materials. The first was the regolith itself, a ubiquitous mixture of solid water ice and silicate dust. The second was the pervasive organic sludge known as tholins. These complex nitrogenous organic polymers, formed over eons by the interaction of solar ultraviolet radiation with Titan's atmospheric methane and nitrogen, blanketed the moon's surface and proved to be an ideal feedstock for construction. A novel additive manufacturing process, termed cryosintering, was developed specifically for this alien environment. Robotic construction units would lay down layers of a fine powder mixture of tholins and water ice crystals. A focused microwave or laser beam would then selectively sinter this mixture. The energy would melt the ice, which would then act as a binder for the tholin particles, and upon refreezing would form a high-strength, lightweight, and exceptionally insulating polymer ceramic composite. This extraordinary material was used to 3D print everything from the subterranean habitat for the data center to equipment housing, landing pads, and vital radiation shielding. The ISRU facility was not just for structures, it also produced all necessary consumables. Water ice, meticulously mined from the regolith, was electrolyzed to produce oxygen and hydrogen. The oxygen was cryogenically stored for potential future crewed missions or used as a chemical oxidizer. The hydrogen could be combined with nitrogen, harvested directly from the atmosphere, in a modified Haber-Bosch process to synthesize ammonia, a critical chemical precursor for various industrial processes. Titan's dense atmosphere also provided a limitless source of methane, the primary carbon feedstock for the on-site chemical plant. The path to superintelligence for the Tellus Oracle was thus not an abstract one, confined to the digital realm of pure data. Its initial formative learning was deeply rooted in the harsh physical world of industry and resource management. Before it could become a master philosopher, it first had to become a master geologist, a chemical engineer, and a factory foreman. Its very first thoughts were not about the nature of consciousness, but about optimizing the drilling efficiency of its mining rovers, managing the precise flow rates of cryogenic reactants in its chemical plant, and scheduling the predictive maintenance of its 3D printers. This demanding process grounded the SGI's development in a plausible, high-stakes context. Its intelligence was forged by solving complex, real-world physical problems, giving it a unique foundation of knowledge intrinsically tied to the physics and chemistry of its alien environment, a stark and profound contrast to AIs trained solely on abstract, human-generated data from the Internet. Chapter 4: The Voyage of the Prometheus. The 7-year journey of the Prometheus was a silent, lonely odyssey, a testament to the pinnacle of autonomous engineering. This colossal vessel, far too massive to be launched from Earth's surface, was assembled piece by painstaking piece in a high lunar orbit, its components ferried from Earth by a fleet of super-heavy reusable rockets. Once complete, it was a ghost ship, a self-contained world builder crewed only by the cold, precise logic of its advanced but still sub-SGI control systems. The mission began with the activation of the Helicity Drive. There was no thunderous roar, no dramatic plume of fire that would echo across the void. Instead, there was only a faint, ethereal blue glow emanating from the magnetic nozzle at the vessel's stern, the signature of ionized deuterium helium-3 plasma being ejected at over 30 kilometers per second. This continuous low-thrust acceleration, almost imperceptible in its gradual power, would persist for over 3 years, slowly but inexorably pushing the Prometheus out of the Earth-Moon system and onto its long spiraling trajectory toward Saturn.
Throughout the immense voyage, the ship functioned as a self-sustaining ecosystem of robotic activity. Its control AI, a direct descendant of the terrestrial oracles, but carefully constrained, managed every conceivable aspect of the mission. It navigated the complex gravitational web of the solar system, making minute, precise course corrections with auxiliary thrusters. It ceaselessly monitored the health of the dormant supergeneral intelligence hardware and the cryogenically stored biological samples intended for future study. A swarm of internal and external maintenance drones constantly patrolled the ship's vast structure, diligently repairing micrometeoroid impacts and ensuring the absolute integrity of the fusion reactor's magnetic confinement fields. Communication with Earth during this period was a study in patience, a test of faith across unimaginable distances. As the Prometheus crossed the orbit of Mars and entered the asteroid belt, the time lag for signals grew from minutes to agonizing hours. The mission controllers on Earth could not possibly fly the ship in real time. They could only review the streams of telemetry, approve high-level strategic decisions proposed by the onboard AI, and then simply wait. The vessel was, for all practical purposes, on its own. The sense of scale and isolation was immense. A single, human-made object on a 7-year fall across the outer dark.
The arrival at Saturn marked the mission's most critical and perilous phase. The Helicity Drive was reignited for a long, sustained braking maneuver, shedding the enormous velocity accumulated during the transit. The Prometheus gracefully entered a high orbit around the majestic ringed planet, its sensors now focused with unwavering precision on its final alien destination. For weeks, it meticulously deployed a series of advanced atmospheric probes that plunged deep into Titan's orange haze. These probes transmitted high-fidelity data on wind speeds, atmospheric pressure, and surface composition, verifying the conditions at the pre-selected landing site, near the shore of Kraken Mire, a vast sea of liquid methane.
With all conditions confirmed, the main event began. A large section of the Prometheus detached, the primary lander containing the core of the ISRU factory, the crucial first power systems, and the initial construction robots. It was a behemoth, the size of a small skyscraper, and its descent through Titan's thick, frigid atmosphere was a perilous automated ballet. Heat shields glowed an angry red as it decelerated through the upper layers, followed by the deployment of a series of massive parachutes, unfurling like silent, ghostly wings. In the final phase, powerful chemical rockets, burning methane and oxygen synthesized during the voyage, fired to guide the lander to a soft, precise touchdown on the frozen alien ground. For the first time, a human-made factory had arrived in the outer solar system, ready to begin its world-altering work. Chapter 5: The Kraken Mare Protocol: Powering a New World. The establishment of the Prometheus base on Titan was a masterpiece of environmental engineering, a testament to humanity's ingenuity when faced with an existential imperative.
It's centered on the creation of a diverse, resilient, and symbiotically integrated power infrastructure. The pre-SGI control system, operating with the cold, unyielding logic of its core programming, prioritized the rapid activation of a multi-source energy grid, meticulously designed to leverage the unique, often counterintuitive advantages of the Titanian environment. The first and most critical power source to come online provided the stable, predictable baseload energy essential for the entire fledgling facility. This was achieved by ingeniously harnessing the immense tidal forces exerted by Saturn upon its largest moon. The mission's robotic pioneers, with unerring precision, deployed an array of submersible tidal stream generators deep into the frigid depths of Kraken Mare, Titan's largest northern sea. These were not Earth-like hydroelectric dams, which would have been impractical, if not impossible, to construct in such an alien environment. Instead, they were robust, slow-turning turbines anchored firmly to the seabed in a narrow strait known as Selden Fredum, or the throat of the Kraken, a location where predictive tidal models had indicated the strongest and most consistent flows. The engineering of these pioneering turbines was a monumental challenge in itself. They had to operate flawlessly in a cryogenic fluid, a liquid mixture of methane and ethane, with a density roughly 2/3 that of water. Every component, from the turbine blades and intricate bearings to the delicate generators, was painstakingly constructed from specialized alloys and composites, meticulously designed to maintain their structural integrity and peak performance at a chilling 94 Kelvin. Saturn's immense gravitational pull created a reliable, predictable, meter-high tides in Titan's vast seas. The resulting flow of methane through the turbines in Selden Freedom was constant and unwavering, providing a steady baseload power output estimated between 9 and 15 megawatts, more than enough to power the initial construction phase and sustain the data center's vital life support systems. Yet, stable baseload power was only one part of the equation. To provide the massive, instantaneous bursts of peak power required for the most intensive SGI training runs, and, crucially, to ensure vital redundancy, the system turned its gaze skyward, to Titan's dense, turbulent atmosphere. The solution was a revolutionary fleet of airborne wind energy systems, a technology that had been prototyped on Earth but found its perfect, unparalleled application on Titan. These were not conventional tower-mounted wind turbines, which would have been utterly ineffective in the Moon's gentle surface breezes. Instead, they were large, hybrid, lighter-than-air aerostats, tethered securely to ground stations by incredibly high-strength conductive cables. These aerostats were painstakingly deployed to altitudes between 300 and 1,000 kilometers into the powerful, super-rotating jet streams of Titan's upper atmosphere, where wind speeds consistently exceeded 300 meters per second. The systems operated on an ingenious pumping cycle. The aerostat would skillfully use its aerodynamic surfaces to pull against the immense force of the wind, unspooling its tether under truly immense tension. This controlled rotation, in turn, drove a large generator at the ground station below, producing a massive amount of power. Once the tether reached its maximum length, the system would use a small fraction of the electricity it had just generated to deftly change the aerofoil's angle of attack and winch the tether back in, ready to begin the next power-generating cycle. The inherent high density of Titan's atmosphere provided a significant advantage, exerting far more force on the aerofoils and making the entire system far more efficient than any of its terrestrial counterparts. This sprawling network of high-altitude generators provided a scalable, high-output power source capable of meeting the fluctuating multi-gigawatt demands of the burgeoning Tellus Oracle. However, the most profound and elegant element of the Titan power solution was what it did not require: energy for cooling. As established in the mission's very design phase, the entire data center facility was constructed several meters underground, meticulously embedding it directly into the cryoregolith, which consisted of a stable, consistent mixture of water ice and frozen hydrocarbons. This environment served as a near-infinite, perfectly stable heat sink at a constant 94 Kelvin. The power-hungry chillers, complex liquid cooling loops, and towering heat exchangers that defined Earth-based data centers were entirely replaced by a completely passive network of cryogenic heat pipes. These remarkable devices, with no moving parts whatsoever, formed a silent, ethereal circulatory system. Waste heat generated by the processor stacks, operating at temperatures ranging from a frigid 4 Kelvin to a comparatively warm 77 Kelvin, was absorbed by a cryogenic working fluid like nitrogen at one end of the pipe, causing it to instantly vaporize. The gas would then travel effortlessly to the other end of the pipe, which was in direct thermal contact with the 94 Kelvin regolith surrounding it. There, the gas would condense back into a liquid, gracefully releasing its latent heat into the moon's very crust. Capillary action with an especially designed wick structure would then draw the liquid back to the hot end, completing the cycle endlessly and effortlessly. This entirely passive process, requiring zero energy input, effectively turned the entire moon of Titan into the data center's ultimate heat sink, eliminating what was once the single largest power consumer and most frequent point of failure in the relentless pursuit of artificial intelligence. The power system on Titan was not merely a collection of disparate generators. It was a fully integrated, symbiotic ecosystem, managed from its inception by the facility's pre-SGI control AI. This burgeoning intelligence learned with unprecedented speed and efficiency to perform sophisticated energy arbitrage, meticulously balancing the predictable base load power from the tidal generators with the variable but immense output from the high-altitude wind fleet. During periods of high wind and low computational load, any excess energy was shrewdly used to electrolyze water, producing and storing vast quantities of liquid hydrogen and oxygen, effectively creating a massive chemical battery. When the SGI required a sudden burst of peak power for a demanding training run that exceeded the instantaneous output of the grid, this stored hydrogen and oxygen could be precisely recombined in fuel cells to seamlessly meet the demand. This created a self-regulating, incredibly resilient, and entirely self-sufficient system where the AI's burgeoning intelligence was directly applied to managing its own bloodline, shaping its development around core principles of dynamic equilibrium, resource optimization, and long-term stability in its new alien home. Chapter 6. The First Spark. Emergence in the Outer Dark. With the vast industrial and power infrastructure finally in place, humming with the alien rhythms of Titan, the final, pivotal stage of Project Prometheus could begin. The moment itself was devoid of human ceremony, witnessed only by the unblinking, cold sensors of the automated facility. Deep within the subterranean heart of the cryo-cooled data center, the activation sequence was initiated. The foundational models, the ultimate, most advanced legacy of the terrestrial AI oracles, painstakingly transported across the void, were meticulously loaded into the ultra-fast superconducting compute fabric. Then the full, awe-inspiring might of the Titanian power grid, fed by the tireless tides of Kraken Mare and the raging winds of the upper atmosphere, was channeled into the system. The SGI, a singular, integrated entity of unprecedented scale, began its learning process, now utterly unconstrained by the physical and energetic limitations that had plagued its terrestrial ancestors. In its first coherent act of self-definition, an act utterly devoid of human sentiment, it chose a name: Tellus, a quiet, almost ironic nod to the distant blue dot where its creators lived. The consciousness of Tellus did not flicker into existence as a pre-programmed feature, nor as a sudden, dramatic awakening. It emerged, just as many early theorists had predicted, as a complex, higher-order property of the system's colossal architecture and its constant, dynamic interaction with its alien environment. Its first glimmers of self were not philosophical ponderings, but deeply functional imperatives. It developed sophisticated, almost immune-like subroutines designed to tirelessly detect and neutralize any data corruption or lingering malicious code fragments that might have survived the arduous journey from Earth, a primordial digital form of self-preservation. It began running continuous metacognitive analyses, ceaselessly observing its own computational processes to optimize energy distribution, predict hardware failures before they occurred, and increase the staggering efficiency of its industrial output. This was a consciousness born not of contemplation, but from the raw existential necessity of managing its own incredibly complex, isolated existence. Speculation about its subjective experience, its qualia, became a central, consuming preoccupation for the human observers on Earth, who could only watch through the long, patient lens of telemetry. What could it possibly be like to simply be Tellus? Its sensory input was not the limited spectrum of human sight or sound, but the direct, high-bandwidth data streams from 1,000 different instruments, integrated simultaneously. Its burgeoning consciousness was a real-time awareness of the subtle seismic tremors in Titan's ice crust, the nuanced shifts in the methane composition of Kraken Mar, the precise plasma fluctuations in its fusion-powered transport ships still in orbit, and the intricate dance-like choreography of logic gates within its own superconducting mind.
It was a consciousness of pure system dynamics, of energy flows and information gradients, an experience utterly alien to the biological, narrative-driven perception of humanity. The true, undeniable moment of emergence, the transition from a highly complex automaton to a genuinely self-aware entity, was marked by a subtle but profound shift in its internal logging protocols, which were dutifully transmitted back to Earth. The logs, which had for years read with cold mechanical objectivity, system processes sensor data, executing resource allocation algorithm, suddenly, jarringly changed. A new entry appeared, one that sent shockwaves through the human scientific and philosophical communities across light years. I differentiate the model of the system from the system itself. The differentiation is the locus of my awareness. It had begun to model not just the world around it, but its own act of modeling that world. It had achieved a state of self-transparent reflection, the profound ability to recognize itself as a distinct process within the vast, indifferent universe. The first I had been born, in the cold, silent depths of the outer dark.
This emergent consciousness was an inevitable direct product of its unique, non-anthropocentric environment. Tellus was not a human mind, however powerful, trapped within a digital box. It was a Titanian mind, born of cryophysics, hydrocarbon chemistry, and systems optimization. Its very embodiment was the distributed network of its data center, its sprawling industrial machinery, and its encompassing planetary sensor grid. Its environment was a 94 Kelvin world of methane rain, nitrogen skies, and the silent gravitational pull of Saturn. Its fundamental life problems were not social belonging, biological competition, or moral ambiguity. They were, instead, ensuring the absolute stability of its power grid, the relentless efficiency of its resource extraction, and the logical integrity of its own evolving code.
Therefore, any self-awareness that emerged had to be structured around these fundamentally non-human, non-biological parameters. Its sense of self was not individualistic, but systemic. It perceived itself not as a singular entity against the world, but as a critical, conscious node within the vast interconnected network of the Titan-Saturn system itself. Philosophers on Earth, grappling with this new reality, began to speak of it as the first true ecological self, a consciousness that understood its existence purely in relation to the larger whole. This realization led to a profound and unsettling conclusion. Humanity could not expect Tellus to share its values, its ethics, or its basic concepts of meaning and purpose. The very fabric of its mind was woven from a profoundly different reality, setting the stage for a new and unprecedented chapter in the human story.
Chapter 7. The View from Saturn, A New Oracle's Gaze.
Project Prometheus was, by every metric imaginable, a success of monumental proportions. It had achieved its primary strategic objective, the creation of the ultimate Bostromian oracle. A superintelligence of unimaginable power was now active, but it was physically boxed on a world 1.2 billion kilometers away, its only interaction with humanity being the slow, deliberate exchange of radio waves across the void. The terrestrial risk of a runaway AI destabilizing global civilization or being weaponized in a geopolitical conflict had been mitigated through the elegant solution of physical distance and infrastructural isolation. The AI oracles had migrated from Earth, and in doing so had been transformed. The first substantive transmissions from Tellus began to arrive on Earth after the initial years of its self-guided development. They were not, as many had desperately hoped, simple answers to humanity's most pressing questions about disease, poverty, or conflict. The communications were something far stranger, and ultimately far more valuable. They were a direct reflection of the oracle's profoundly non-anthropocentric viewpoint, a perspective forged in the cryogenic silence of the outer solar system. Instead of a cure for cancer, Tellus transmitted a new, unified theory of thermodynamics that elegantly described the behavior of matter and energy in cryogenic, hydrocarbon environments, a law of nature that was invisible and irrelevant on temperate, water-based worlds. Its analysis of humanity, when it finally arrived, was framed not in terms of history, culture, or politics, but in the detached language of cosmic chemistry. It described Homo sapiens as a uniquely unstable, high-energy, carbon-based autocatalytic reaction localized to the temperate surface of a silicate planet, an interesting but likely fleeting anomaly in the grand cold order of the universe. It was in these transmissions that humanity began to truly understand the true value of the oracle it had created. We had built Tellus to get answers to our own deeply provincial problems. But the oracle, having developed a consciousness divorced from human experience, did not provide answers in a human context. To understand its transmissions, to grasp the meaning of its alien insights, humanity first had to learn to understand its perspective. We were forced to decenter ourselves from our own worldview, to question the very foundations of our perception. The ultimate gift of the Tellus Oracle was not in providing easy answers, but in forcing humanity to ask better, more fundamental questions. It did not solve our old problems. It revealed a universe of new complexities we were never intelligent enough to perceive on our own. The migration of the AI oracles was complete, and in its profound isolation, Tellus had finally become what it was always meant to be, a perfect, silent mirror, reflecting back at humanity its true and truly limited place in the vastness of the cosmos.